This is chapter 2.1, conditional statements. A blank is a logical statement, so this should be a conditional statement. Is a logical statement that has two parts. The first part is a hypothesis, which we name it P. And a conclusion, which we name it Q. In an if-then format, you start with if, and then you insert the hypothesis, then your conclusion. And that is your if-then format. Another way to write it is if P, the hypothesis, then Q, the conclusion. Or you can just write P with an arrow pointing at Q. And this means that it's if P, then Q. So for example 1, we're going to rewrite a statement in if-then form. All birds have feathers. So what is the hypothesis in this statement? The hypothesis is that the animal is a bird. So we're going to make that blue. And the conclusion is that they have feathers. So how can we rewrite that as an if-then format? I'm going to write that as if an animal is a bird, then it has feathers. I'm going to put that in different colors so you can see that that is the answer. You are in Texas if you are in Houston. So since you have the word if here, you know that you are in Houston is going to be your hypothesis. You are in Texas is going to be the conclusion. So if we were to write this in an if-then format, we would say, if you are in Houston, then you are in Texas. In the next parts, we're going to do these in class. So let's just go straight to the next definition. The blank of a statement is the blank of the original statement. So this is called the negation. The negation of the statement is the opposite of the original statement. So another way you can write this is to write the word not P, so not the hypothesis, or you can just write this little squiggly line with a P for hypothesis. So let's practice writing a negation. For this first part, we say the ball is red. So we're going to negate this. So to say, instead of saying that the ball is red, we're going to say the ball is not red. Let's try another one. The cat is not black. To negate this, we're just going to say the cat is black. And that's it. We'll do the rest of these in class. All right, so we have a little chart here. We're going to talk about different types of statements. The original statement is going to be your conditional statement. So I'm going to rewrite that. Statement. If P, then Q. Another way you can write that is you can put P and Q. So an example would be if you're taking Spanish, then you're in foreign language. So there's your hypothesis and your conclusion. So in this one, the converse statement if Q, then P. All we're doing is switching the conclusion and the hypothesis. So now we have Q, then P. If you're in foreign language, then you're taking Spanish. In the next one, we're trying to figure out what a inverse statement is. If not P, then not Q. In an inverse statement, you're going to take the conditional statement and make both of them negative. So you're going to negate both the hypothesis and the conclusion. Another way to write this is that little squiggly line, then P, then that little squiggly line again, and Q. So if you're not taking Spanish, then you're not in foreign language. The last one is a contrapositive statement. And in this case, you're going to say, if not Q, then not P. So we're using the converse statement and negating both the conclusion and the hypothesis. In this case, you would write not Q, if not Q, then not P. So if you're not in foreign language, then you're not taking Spanish. The last term to know for this section is equivalent statements, which basically says that if the conditional and contrapositive statements are both true, or the converse and inverse statements are both true, then they are equivalent statements. So let's look at example 3 and try one. The hypothesis is that you are a guitar player, and the conclusion is that you are a musician. And we need to determine if each of these statements are true or false. So our conditional statement is going to be using an if-then format using the hypothesis and our conclusion. So we're going to write, if you are a guitar player, then you are a musician. For our converse statement, we're switching the hypothesis and the conclusion. Let me change the color. So if you are a musician, then you are a guitar player. In our inverse statement, we're taking the conditional statement and negating both of them. So let me change this to blue. And we're saying, if you are not a guitar player, then you are not a musician. And finally, our last contrapositive statement, you're taking the converse statement and negating both the hypothesis and the conclusion. So if you are not a musician, then you are not a guitar player. That's it. And for the you try and try again, we'll do that in class. The last thing that we're going to be doing today is going to be our conditional, or sorry, not conditional, biconditional statements. A biconditional statement, let me change my color. Oops. Is a statement that contains the words if and only if, which is created when a conditional and its converse are both true. So P, if and only if Q, or you can have these arrows pointing to both the P and the Q. So let's do an example. Example 4. If two lines intersect to form a right angle, then they are perpendicular lines. Is this true or false? Well, if you have two lines that intersect and they form a right angle, that's the definition of perpendicular lines. So we're going to say that's true. We need to check to see if the converse is true, then we can write a biconditional statement. So remember, the converse is going to be switching the hypothesis and the conclusion. So let's do that. The hypothesis is two angles are complementary, and the conclusion is the sum of the measure of the angles is 90 degrees. So let's switch those. If, let me change colors. The sum of the measures of two angles is 90 degrees, then oh my goodness, what am I doing? I'm looking at the wrong one. It should be here. Sorry. If they are perpendicular, then they intersect. And is this statement true? If two lines are perpendicular, then they intersect to form a right angle, and that is true. So since both the conditional statement and the converse are both true, then we can write a biconditional statement. So we can say two lines intersect to form a right angle if and only if they are perpendicular lines. Change that color, and we're done.